Hi, today we are diving into a crucial aspect of generative AI that allows us to move beyond generic capabilities and truly make these powerful models work for our specific needs. Customization and fine-tuning. It's about transforming a general purpose AI into a specialized expert for your domain, your data, and your unique challenges. Let's explore how we can achieve this. So why bother with customization? While off-the-shelf models are incredibly powerful, they are by nature generic. They lack specific domain knowledge. For instance, they won't inherently know the intricate details of our organization's proprietary products, internal policies, or specific engineering standards. This can lead to outputs that don't match our desired tone, style, or worse, result in hallucinations or inaccurate information when asked about niche topics. There are also significant security and privacy concerns when feeding proprietary data into public models. Customization directly addresses these limitations. By tailoring the AI, we gain several key benefits: improved accuracy, grounded in our own data, enhanced relevance for our specific context, a consistent style and tone aligned with our brand, and a significant reduction in hallucinations. It also allows better data privacy by keeping sensitive information within our control, especially with methods like RAG. There are several levels of customization, each offering different trade-offs in effort, cost, and impact. First, we have prompt engineering. This is about crafting clear, effective instructions, providing examples, and adding context to guide the model's output. It's great for quick wins and guiding behavior without changing the model itself, and it's fast and cheap. However, it's limited by the model's base knowledge and can sometimes be inconsistent. Next, Retrieval Augmented Generation or RAG. This method connects the LLM to an external knowledge base. Think our internal documents, databases, or organization-specific technical manuals. The LLM then retrieves relevant information from our sources before generating a response. RAG is fantastic for providing up-to-date factual answers, significantly reduces hallucinations, and keeps our proprietary data private. The challenge lies in managing that external data and ensuring the retrieval process is accurate. Finally, we have fine-tuning. This is where we take an existing pre-trained model and continue to train it on a smaller, highly specific data set of our own. Fine-tuning actually adapts the model's core knowledge, style, or capabilities to our domain. It can lead to significant performance improvements but requires high quality data and more compute resources, making it more complex. Let's take a deep look at fine-tuning. At its core, fine-tuning is about adapting a powerful pre-trained LLM to a specific task or domain by continuing its training process on a new, much smaller and highly relevant dataset. This process subtly adjusts the model's internal weights, making it more proficient in our specific context. You should consider fine-tuning when you need domain adaptation, style and tone alignment, specific task performance, and model size and cost reduction. In domain adaptation, you want to teach the model organization-specific terminology, internal processes, or complex engineering concepts. Style and tone alignment ensures all AI-generated outputs consistently match our corporate communication guidelines and brand voice. If you have a very particular task like classifying internal documents, extracting specific entities from reports, or generating highly specialized summaries, fine-tuning can significantly boost accuracy. And this is a use case of specific task performance. And importantly, a smaller fine-tuned model often can achieve performance comparable to a much larger, more expensive generalist for a specific task. There are also different types of fine-tuning. Full fine-tuning updates all model parameters, which is resource intensive. More commonly now we use parameter efficient fine-tuning or PEFT, such as LoRa, which updates only a small subset of parameters, making it much more efficient and requiring less data. Another technique is QLoRa, which is a quantized version of LoRa coming from the quantization we discussed last time. There are other PEF techniques such as prefix tuning or prompt tuning and adapter layers, which can significantly reduce the fine-tuning footprints of LLMs. Regardless of the customization method, data is king. Its quality, relevance, and even quantity are absolutely paramount. For RAG, the effectiveness hinges on having clean, well-structured, and up-to-date internal documents along with robust indexing and retrieval mechanisms to find the right information quickly. For fine-tuning, the demands are even higher. You need high-quality, labeled data, clear examples of what you want the model to do. This data must be domain-specific, reflecting your exact use case. You need a sufficient quantity, often hundreds to thousands of examples, depending on the complexity of the task. And it needs diversity to cover various scenarios and edge cases. Crucially, data preparation, cleaning, formatting, deduplication, and annotation is often the most time-consuming and labor-intensive part of any customization effort. Investing here pays dividends in model performance. As we embark on customization, here are some key considerations. First, start simple. Often, robust prompt engineering combined with a well-implemented RAG system can achieve excellent results and is far more cost-effective than immediate fine-tuning. Second, evaluate thoroughly. Always measure the impact of your customization on performance, accuracy, and critically, the reduction of hallucinations. Third, weigh the cost versus benefit. Fine-tuning is an investment in time, data, and compute. Ensure the return on investment is clear for your specific use case. Fourth, data governance and security are non-negotiable, especially when dealing with sensitive organization data. Ensure your chosen method complies with all internal and external regulations. Fifth, remember that customized models and RAG systems require ongoing maintenance. Data needs to be updated and models may need periodic retraining. And finally, always adhere to ethical AI principles. Ensure your customization efforts don't inadvertently introduce bias or create harmful outputs. By carefully considering these points, we can effectively leverage customization and fine-tuning to build powerful, tailored generative AI solutions for our organization. To quickly summarize our deep dive into customization and fine-tuning, remember that tailoring is essential for generative AI to meet our specific organization needs. Choose the right method, whether it's prompt engineering, RAG, or fine-tuning, based on your specific goals and resources. Always prioritize data quality. It is absolutely paramount for successful customization. Evaluate and iterate continuously to refine your approach and ensure optimal performance. And finally, think long term about the maintenance, cost, and ethical implications of your customized AI. By embracing these principles, we can truly make generative AI ours, transforming it into an invaluable specialized tool for our organizations. If you find this content useful, please like, share, comment and subscribe for similar content. See you in another video. Until then, elevate.